Laws of exponents. So these are going to be rules that are really shortcuts to helping you figure out how to solve things when there are exponents. So let's write that down. So these are going to be shortcuts to make simplifying exponents easier. All right, so they're just shortcuts to make simplifying exponents easier. All right, let's go right to the first one here. So the first law says when you multiply numbers or variables with the same base, that's important. Remember what the base is. So here, let's say this was x to the y power. This is the base, right? This is the exponent. Just as a reminder here. So when you multiply numbers or variables with the same exact base, you can add the exponents as a quicker way to solve it. So here's how they write that. They say, let's say you have a to the, I don't know, x power times a to the y power. A shortcut for solving that would be a to the x plus y power. Okay, let's box that. That's the first law. Let's look at why this is true. So, and I think you'll understand it once you see it out. So let's say you had something like, here, number one, x to the fourth power times x to the third power. Well, before you knew this shortcut, what would you do to figure this out? I mean, what does x to the fourth mean? You could write it out, expand it out. X to the fourth means x times x times x times x. What does x to the third mean? X times x times x. What is all that together? 1, 2, 3, 4, 5. X to the seventh. A shorter way to have done that? Look, 4 plus 3, 7. But that's why this law works, okay? Because as long as you have the same base, that will happen. Let's try it with numbers, just so you can kind of, sometimes that's easier. So let's say 2 to the third times 2 to the second, right? Well, let's do it before you knew the law. So 2 to the third is 8 times 4, that's 32. If you use the law, you keep the 2, the base. So the base, you just drag it over. The exponents is the only math you have to do. 3 plus 2 is 5. And 2 to the fifth, 2, 4, 8, 16, 32, same answer. So just a little shortcut. Maybe with numbers you would like to do it this way, fine. You get the same answer. I can't say that's a wrong way to go. But when we have variables, the only way to simplify it is going to be to use the law. Okay, so let's just try a bunch of these. All right. So here we go. Let's try m to the fifth times m to the seventh. M to the 12th. That's all you can do. All right, let's try another one. X to the second times x to the third times y to the fourth times y. Oh, this one's interesting. Okay, so only with the same base can you put this together. So we're going to get x to the fifth. Then we're going to get y. Hold up. What exponent is on this y right here, even though it's not drawn in? It's actually a 1, because y to the first power is just y. 4 plus 1, so this is y to the fifth. Okay. All right, try another one like that. Let's see, we've got a to the 5th, b to the 2nd times a. See what you would get for that one. That should be a to the 6th, b to the 2nd. Because again, you could draw it in. You could draw the 1 in there. Might be a good idea. Okay, now I will definitely try to trick you. Try this. 2x to the 3rd. Now that exponent is just on the x, okay, because there's no parentheses, times 4x to the 3rd. Now, a hint, the laws of exponents are only used on exponents. So these numbers here, the coefficients, if you will, that's just 2 times 4 is 8. So you're going to multiply if there's any coefficients. Here's where it gets tricky. What are we going to do with the 3 and 3? We're actually adding them because we're using the laws of exponents. So that's 8x to the 6th. All right, try this one. Negative 6y to the 5th times 4y to the 2nd. Careful. All right, so negative 6 times 4 is negative 24. Y to the 5th times y to the 2nd is y to the 7th. All right, so that's the idea for those. So the first law, and again, you know what? If you forgot the law, you can always expand it out and you will get the right answer. That's actually going to be true for basically every law of exponent we're going to learn. You could always expand it out and get the answer. If you memorize the shortcut, obviously it makes your work a little faster, but you should be able to get the right answer either way. Okay. All right, let's go to the second one here. So the second law, I call it the second one. I don't know if they actually have numbers, but this one is called power to a power. Okay, so to find a power of a power, you're going to multiply the exponents. Okay, how do they write that? They write it like this. So if you have a to the x all to the y power, so that's a power raised to a power, okay? You keep the base, and you're going to multiply these exponents. So x times y, x, y. Okay, so this is power to a power. All right, let's look at y so you can kind of understand where it's coming from. If we did an example, let's try first with numbers here. So let's say you had 3 to the 2nd all to the 3rd power. If you were going to expand this out, right, this would really be your base. 3 to the 2nd is the base for this exponent. So you would write this out. It wants 3 to the 2nd times itself 3 times, right? Boom, boom, boom. Now use what we just learned before. Look what you have here. You have the same base multiplied together. What would you do with these exponents? You would add them. 2, 4, 6. You would get 3 to the 6th power, which, if you're curious, is 729. So 2 times 3, we could have gone right to 6, right, without expanding it out. Or we could have expanded this out. What's 3 to the 2nd? 3 times 3. How many 3's do you have? 2, 4, 6. There you go. So again, expanding it out will get you there. The laws are supposed to help you get there quicker. All right, let's try one with a variable. How about x to the 4th to the 2nd power? All right, again, you could expand out what we just know here. We could use the law we just learned, or you could have just went 4 times 2, boom. Well, hopefully this explains why this law works, right? Power to a power. Okay, let's try a bunch. Okie dokie. Let's say 2 to the third, all raised to the second power. And try to solve it all the way. If there's numbers and you can solve it all the way, go ahead and do that. So what do I mean? So this would be 2 to the sixth. You can solve 2 to the sixth. 2, 4, 8, 16, 32, 64. All right, if there's a variable, obviously you can't go any farther. But if it's just numbers, you should try to simplify it all the way. All right, 2. Let's do a variable here. C to the fifth, all to the fourth power. You could expand it out or use the law. That would just be C to the 20th power. Okie doke. How about M to the third, all to the 9th power? Hopefully you said M to the 27th power, and that's it. What if you have a couple things in there? What if it was M to the second, N to the third, all raised to the second power? Okay, so now this exponent 2 has to go to everything in the parentheses, kind of like you're distributing it. So M to the second is raised to the second. So that's M to the fourth. N to the third is raised to the second. So that's N to the sixth. Okay, so this outside the parenthesis has to go to everything. All right, now this is mean. 3 x to the fourth raised to the second. All right, there's a few ways to think about this. The 3 really has an exponent of 1, so this is going to turn into 3 to the second, x to the 8th. But 3 to the second you can solve. 3 to the second, that's 9, right? 3 times 3. So that is your answer. And I would be okay if you jumped right to this answer, but you have to, so again, the coefficients are being treated differently. They are just a number, that's 3 to the second power. And then power to a power is multiplying. Woo. Try another one like that. Try 2x to the third y, all raised to the third power. Okay, so this is 2 to the third power, that's 8. X to the third raised to the third is x to the 9th. Remember the y has an exponent of 1, so this is y to the third. Oof. Try another one like that, see if you can get it. 5a to the 7th, b to the third, all raised to the second power. Okay, hopefully you got 25, because 5 to the second, a to the 14th, b to the 6th. All right, last one. 9, x to the third, y to the second, x to the second, all raised to the third power. Okay, 9 to the third. 9 times 9 is 81. 81 times 9 is 729. Then I would have x to the 9th, y to the 6th, x to the 6th, but I can put these x's together. So it's not simplified all the way yet. All right, so it's 729 x. Now this is the first law. We're multiplying the same base. So I'm adding the exponents, and the y to the 6th stays the same. right? So not tricky laws, but when you intertwine them, they could get confusing. So go slow, refer to your notes if you need to. You've got 2 laws to worry about. When you're multiplying the same base, you add the exponents. When you're going power to a power, you multiply the exponents. Okay? All right. Good job.